Astatine is a radioactive chemical element with symbol A, T, and atomic number 85. It is the rarest naturally occurring element in the Earth's crust, occurring only as the decay product of various heavier elements. All of Astatine's isotopes are short-lived. The most stable is Astatine 210, with a half-life of 8.1 hours. A sample of the pure element has never been assembled, because any macroscopic specimen would be immediately vaporized by the heat of its own radioactivity. The bulk properties of astatine are not known with any certainty. Many of them have been estimated based on the element's position on the periodic table as a heavier analog of iodine, and a member of the halogens, the group of elements including fluorine, chlorine, bromine, and iodine. Astatine is likely to have a dark or lustrous appearance and may be a semiconductor or possibly a metal. It probably has a higher melting point than that of iodine. Chemically, several anionic species of astatine are known and most of its compounds resemble those of iodine. It also shows some metallic behavior, including being able to form a stable monatomic cation in aqueous solution, unlike the lighter halogens. The first synthesis of the element was in 1940 by De La Corson, Kenneth Ross Mackenzie, and Emilio G. Segar at the University of California, Berkeley, who named it from the Greek astatos, meaning unstable. 4 isotopes of astatine were subsequently found to be naturally occurring, although much less than 1 gram is present at any given time in the Earth's crust. Neither the most stable isotope astatine 210, nor the medically useful astatine 211, occur naturally. They can only be produced synthetically, usually by bombarding bismuth-209 with alpha particles.